What's up, everyone? Welcome back. Patrick here. Moving on to the next example. We have a couple of functions here to differentiate. A little more practice using the chain rule. So this first function, we got f of x equals pi to the power of 3 minus 5x cubed to the power of 7. And so notice that what's the outer function? It's this power of 7 here. And then we have this inner function, pi to the 3 minus 5x cubed. So what would the derivative here be? Well, we would first have to bring the 7 down, right? The inner function would stay the same. Subtract 1 from the exponent, and then we have to multiply it by the derivative of the inner function. Now you got to be careful here. This pi cubed, pi is not a variable, that's a constant, right? So a lot of times students will derive this. They'll be like, oh, it's 3 pi squared, they'll put here. Okay, but the derivative of a constant is just 0, right? So this is just a constant, that becomes 0, so then the derivative of negative 5x cubed would be what? Negative 15x squared, like that. So be careful with these little tricks. Sometimes you'll also see the constant e, right? You'll have like e to the power of 3 maybe, minus 5x cubed, and e is just a constant as well. The derivative of e to any constant is just going to be 0. So just be on the lookout for those constants floating around. And then to simplify this, we could just take 7, multiply it by negative 15x squared, which would end up being what? Negative 105x squared. I'll put that in the front. And then we got pi cubed minus 5x cubed to the power of 6, like that. Right, so just derive the outer function, brought the exponent down, kept the inner function the same, then took the derivative of the inner function. Just in general, what happened was we had a function to the power of an exponent. The derivative of that is going to be bringing the exponent down, keeping the inner function the same, subtracting 1 from the exponent, then multiplying it by the derivative of that inner function. Now moving on to the next function, we got f of x equals negative 5x squared over the square root of 3x plus 1. And then I'm going to rewrite this. Okay, instead of putting this root here, I'm just going to change the root to be 3x plus 1 to the power of 1/2, like that. Okay, so let's go into deriving this. Now here, we're going to have to do the quotient rule. But then notice that within the quotient rule, when we derive this denominator, we're going to have to do the chain rule. Because like in part A, it's basically a function to an exponent. So we're going to be using that same methodology of bringing the exponent down, subtracting 1 from the exponent, keeping the inner function the same, then multiplying it by the derivative of the inner function. That's going to be all within the quotient rule. So within the quotient rule, we know that there's basically going to be what? There's going to be 4 brackets, and there's going to be a subtraction in the middle there. So I like to write out those 4 brackets initially just to organize my work and my thinking. And then we know it's going to be whatever function is in the denominator, and we're going to square that, right? So when we square the root of 3x plus 1, the power 2 and the root just cancel out. So we know we're just going to be left with a 3x plus 1, like that. Okay, so let's go into filling in these brackets. This first bracket's going to be the derivative of the numerator. Derivative of negative 5x squared is what? Negative 10x times the bottom left as is. So that's just going to be 3x plus 1 to the power of 1/2, like that. Minus the numerator left as is. So that's going to be negative 5x squared. And then here, we got to take the derivative of the denominator. As I mentioned, we got to do the chain rule. Kind of running out of room here a little bit, but I think I will fit it in here. So 3x plus 1, we got to subtract 1 from the exponent. And then we got to multiply it by the derivative of the inner function. So what's the derivative of 3x plus 1? That's just going to be 3. Like that, right? And so we now have to simplify everything. So making this look a little nicer, let's get rid of some of these brackets. Over here, there's nothing really to multiply together, so let's keep the negative 10x and then the 3x plus 1 to the half, separated like that. Now these two negatives make a positive, and then we got 1/2 right here times 3 times 5x squared, right? The two negatives here, they canceled out, so there's a positive. So 5 times 1/2 times 3, that's going to give us what, 15 over 2 like that, and then we have that x squared, and then we got the 3x plus 1 to the negative 1/2 like that. And that's going to be all over 3x plus 1 like that. Okay, so now what we have to do is basically simplify the numerator by factoring out the common factors. So notice I could definitely take out an x, because we got an x here, we got an x squared here. I can also take out, so I'm going to take out a -5. I'm actually going to take out a -5 over 2 because I want to get rid of this denominator here. So I'm going to take out, let me think. Yeah, I'm going to take out a -5 over 2. And I'm also going to take out an x. And then I could also take out a 3x plus 1 to the lowest exponent between half and negative 1/2. The lowest exponent is negative 1/2, like that. Okay, so what would I be left with here? Well, the x I took out. If I take out -5 over 2 from -10, right, so I would divide -10 by -5 over 2, that would give me what? The negatives cancel out. We'd have 20 over 5, which would be 4, like that. So there would be a 4 left over here. And then if I'm taking out 3x plus 1 to the negative 1/2 from a positive 1/2, I would be left with 3x plus 1 to the power of 1, which we don't have to write, right? So basically I had a 3x plus 1 to the half, and then I took out a 3x plus 1 to the negative 1/2. And so you'd keep the bases the same and you'd subtract the exponents and you'd end up with a positive 1, right? So there's a 3x plus 1 to the exponent positive 1, and then that positive 1, you don't really have to write it. So let me erase some stuff here. And now what would we be left with in this second expression? Well, because we took out a negative from a positive, now that's going to be a negative. And then taking out -5 over 2 from 15 over 2, that would be, we'd be left with what, a 3 there, right? We only took out an x. There's an x squared here, so there's still an x left over. And I think that's it, because this entire 3x plus 1 to the negative 1/2 we took out. So there's like a 1 left over here, which we don't have to write. Okay, so that I think would be it. Close that bracket off, and that's going to be over 3x plus 1, like that. And that's to the power of 1. And the reason why I'm writing it in brackets like this to the power of 1, because eventually I'm going to bring this down, and then we're going to combine those because they have the same base as exponential expressions. So now let's take this and further simplify. So I'm going to continue this up here. So let's be super careful. Now this 3x plus 1 to the negative 1/2, like I mentioned, I'm going to bring that down. And then I'm also going to bring down this denominator of 2, right? We don't want to leave a fraction in the numerator. So I'm going to split this -5 over 2. I'm going to keep the -5 up top. I'm going to bring the 2 down. So what would we be left with at the top? We'd be left with this x. Actually, sorry, we'd be left with a -5x, right at the top, these two, basically. And then we'd be left with this bracket here. Now, what's this going to simplify to? We've got to distribute the 4. So we'd have 12x minus 3x, which would give us 9x. And then we'd have 4 times 1, which is 4, like that, right? So this bracket here would simplify to 9x plus 4. And then we can't really simplify that any further, can't factor anything out. Okay, so we're going to leave it like that. And then in the denominator, what happened? We brought this 2 down. So let's write that. And then we brought this 3x plus 1 to the negative 1/2 down. So that became 3x plus 1 to the positive 1/2. And then we still got that 3x plus 1 to the power of 1. And then notice that these two, as I mentioned, they have the same base. So when we're multiplying two exponential expressions with the same base, we could add the exponents. What's 1 plus 1 over 2? 2 over 2 plus 1 over 2, that gives us 3 over 2. And so what would end up happening is we'd have negative 5x, 9x plus 4 over 2, 3x plus 1 to the power of 3 over 2, like that. And that ends up being your final simplified derivative. Right, so these ones are pretty tough, especially when you're dealing with like negative exponents in the numerator, right? Within the quotient rule, you got to factor that out and then play around with it, and then you'd end up with like these positive exponents. So just be careful with your algebra at the top there when you're factoring. That's where most of the mistakes are made. But as long as you're super careful, then you should be getting the correct answer. Yo, what's up? Quick little intermission here. Wanted to mention a few things quickly and we'll get right back into the question. First off, if you are getting value from this video, if you can please like the video and subscribe to my channel, it does help me out a lot. Number two, if you're watching this on YouTube, you can go to the description box and there is a link that will take you to my website, allthingsmathematics.com, where all my courses are organized so you can watch the videos in order, and I'd recommend doing so because lots of concepts carry over from one video to the next. Also, for lots of the courses, at the end of the chapters, you can find tests that you can practice with, and the tests have video solutions as well. Number three, if you feel like you need personalized help in tutoring, give me a shout. I currently tutor students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. You can text me. We can discuss availability and then we can book a session. My contact details are on my website. And lastly, feel free to forward the website to any of your friends who are also taking the course, who you feel can benefit from these videos as well. Hit me up on all my socials. It's All Things Mathematics for all of them. Back to the video we go. And then moving on to part C, we got this final function f of x equals the square root of 5x minus 4 to the power of 4 times 3x minus 5 to the power of 6. Now, what I would do here before deriving it is simplify this function first. There's lots of opportunities to simplify it, so let me show you. First thing I'm going to do, as usual, is any roots. I'm going to rewrite that as rational exponents. So this square root, I can rewrite that as to the power of a half, and that's basically that entire expression, right, under the root. So we'll put that all in brackets. Now, if you want, I wouldn't suggest it, but if you want, you could derive it from here, right? So you could bring the 1/2 down, keep this the same, then do negative a half, and then you got to take the derivative of all of that, which you're going to have to do the product rule, and then within the product rule on each of these, you're going to have to do the chain rule, or the power of a function rule, which is just a special case of the chain rule. So you can do that, but notice what else can you do? Well, we could take this 1/2 and distribute that exponent to both of these expressions, because there are two expressions that are multiplying, right? If you remember your exponential rules, whenever you have two things that are multiplying inside a bracket and there's an exponent on the outside, I could take each of those things to that exponent on the outside, right? Same thing if they were dividing. If it was like a over b, you could do a to the power of x over b to the power of x. Now you can't do it if they're adding, right? If it was like a plus b to the power of x, right? That does not equal a to the x plus b to the x. But if they're multiplying or dividing, you can distribute that exponent. And notice that these two expressions, they're multiplying, right? And so that's what I would do. I would distribute that exponent and then simplify these first. And then the derivative or the function that you're going to derive is going to be a lot more simple, right? So you wouldn't be able to do that again if there was like a plus or a minus in between these. Then that would be a lot more hectic. Then you have to derive it from this point, right? You'd have to do the chain rule with the 1/2 on the outside. But what I'm going to do is I'm going to first further simplify. So I'm going to take this 5x minus 4. Actually, I'm going to need a couple of brackets. So look, I take the 5x minus 4 to the power of 4. I take that to a half. And then this 3x minus 5 to the power of 6, I'm also going to take that to the half. And then notice 4 times a half, that's 2. So we end up with 5x minus 4 to the power of 2, 3x minus 5 to the power of 3. And then from here, what I would do is now derive that function, right? This function and this function, they're the exact same thing. But we took some time and some steps to simplify the function first before deriving it, and now our differentiation process is going to be a lot less hectic. So taking the derivative of this new function, we're going to have to do the product rule, right? So there are two functions multiplying. And so let's write out our 4 brackets, and then I'm going to write out the other 2 brackets over here. Kind of running out of room here a little bit, like that. Okay, so taking the derivative of this first one, what do? Bring the 2 down, 5x minus 4 to the power of 1, then multiply it by 5, like that. Multiply it by the derivative of the inside. And this function here, 3x minus 5 to the power of 3, we keep the same. Then this next bracket, keeping the first function the same, and then we derive this second function here. So bring the 3 down, keep the inner function the same, 3x minus 5 to the power 2, then multiply by the derivative of that inner function, which is just 3, like that. Okay, so now what's going to happen, let's actually put this a little higher. So let's make this look a little nicer. 2 times 5, that is just what? 10. Then I got 5x minus 4. That's to the power of 1. We don't have to write the 1, but I'm going to, because after we're going to have to factor, and we'll just see more clearly what we could take out. And then over here, 3 times 3, that's 9. And we'd be left with what? 5x minus 4 to the power 2. That function stayed the same. And then this one here, we ended up subtracting 1 from the exponent, like that. Right, so making this look a little nicer, and now from here, what we got to do is basically factor from both of these expressions. Now, with the 10 and the 9, can't really factor anything out of that. So those would stay. Now, notice that there's a 5x minus 4 in both of these, but we always factor out what? The lowest exponent between 2 and 1. Lowest exponent is 1. So I'm going to take out a 5x minus 4 to the power of 1. And then we got a 3x minus 5 to the power of 3, 3x minus 5 to the power of 2. Lowest exponent is the 2. So I'm going to take out a 3x minus 5 to the power of 2, like that. Okay, and so what would we be left with in the brackets? The 10 still stayed in this original expression. The 5x minus 4 we took out fully to the power of 1. And then there's 3x minus 5 to the power of 3. We took out 2 of them, so there's still 1 left over. And then we got a 9 still left over for this expression. The 3x minus 5 to the power 2 took that out. There's 2 5x minus 4s. We took only 1 of them out, so there's still a 5x minus 4 left over, like that. Okay, and so simplifying this, 5x minus 4, don't have to write that 1 anymore. 3x minus 5 to the power of 2. And then you want to simplify this bracket. Let's actually just put circle brackets. So distribute, okay, so this would be what, 30x plus 45x, that would give us what, 75x. Then we have negative 50 minus 36, which would give us minus 86, right? Yeah, minus 86, like that. And then you always want to check, can you take something out of this bracket? Can you factor this bracket any further? Maybe put something in front, but between the 75 and the 86, no common factor there. And then there is only an x variable here. There's no x variable attached to this constant, right? So that right there ends up being your final answer for the derivative of this last function. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.